The following is an OPB original series.
Oregon Experience is a production of OPB in partnership with the Oregon Historical Society. Leading support for Oregon Experience is provided by the Harold and Arlene Schnitzer Care Foundation, Arlene Schnitzer and Jordan Schnitzer, and the Robert D. and Marcia H. Randall Charitable Trust Fund for Lifelong Learning. Major support provided by the Clark Foundation. Additional support provided by the contributing members of OPB and viewers like you. Thank you.
NASA came to Central Oregon looking for a place to have their astronauts train that would be kind of similar to the terrain that they thought they would find on the moon.
When we sent astronauts up there, it wasn't clear what they were going to find. We knew that there had to be volcanic rocks. Central Oregon is probably one of the few places on Earth where you can, within a few hours, see virtually every type of volcanic feature.
The main thing was to expose them to as many different geological experiences as we possibly could. Get them out in the field.
You couldn't just say, go to the surface of the moon and just pick up whatever you have. You just find any old rock. You had to know what you were doing.
Oregon played a very pivotal role in determining the current understanding of the formation of the moon.
It was like the world came to bend.
The Challenger has landed.
Roger, Challenger, that's super.
Okay, Bob, I've got my tools of the trade right here.
Before Apollo astronauts walked on the moon, they trained in the lava fields of Central Oregon.
We didn't even know if the moon was a solid surface or if it was a deep powder surface. We didn't know if the rock fields were sharp or dull. We had no idea.
Personnel from the Manned Spacecraft Center are getting a preview of another world in this area of Central Oregon.
Central Oregon is probably one of the few places on Earth where you can, within a few hours, see virtually every type of volcanic feature. The places they focused on were Hole in the Ground, Fort Rock, Lava Butte, Newberry. And those 4 places really cover the spectrum of volcanic features that they might encounter on the moon.
The Pacific Northwest is one of the most volcanically active areas in the United States. The landscape was created through numerous volcanoes, including Newberry, just south of Bend, an active volcano that the U.S. Geological Survey classifies as a very high threat. Stretching almost 1,200 square miles across Central Oregon, it is one of the largest volcanoes in the continental United States.
Some moon lava may consist of material that is smooth and glassy. A classic example exists in a black obsidian flow located on the inward slopes of Newberry Crater.
I think the main goal there, and in other places they went, was more or less just to train the astronauts to look at the samples and identify minerals and features. The astronauts weren't trained in this sort of thing at all. Most of them were pilots. And so they had to make this sort of jump into almost a completely new field.
The actual makeup of the chemistry of the moon was unknown. So it was important that we should get samples of that material to determine, what's it made of.
The moon is less than a third of the size of the Earth. It is thought to have formed about 4.5 billion years ago and is slowly moving away from us. For centuries, telescopes provided the only detailed views. That changed in the late 1950s with the Russian launch of the first satellite, Sputnik, followed by a series of other successful missions.
Now, Soviet science has rocketed to the moon. These are the first actual photographs of its hidden face. And American satellites from the Vanguard to the Pioneer have given us priceless information as well. But the new contest is the race to put a man into space.
The Soviet Union had sent Yuri Gagarin not only into space, but actually into a full orbit. So the Soviet Union was still way ahead of the United States. So the United States reacted by boosting up its space capability.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Throughout the 1960s, the nation invested billions of dollars and employed hundreds of thousands of people dedicated to a successful moon landing. But it took years of trial and error as NASA worked to figure out complex problems that had never been tackled before.
It took great courage at every level. You know, we think about courage of the guys that actually made the flight to the moon. But everybody's career was at stake at that point, and they did their part.
Before missions that actually went to the moon, they were concerned that the moon's surface would be so fluffy that possibly if astronauts tried to land there, they might sink into it like quicksand.
And so we had to spend some time sending unmanned probes there, specifically the surveyor landing craft, to make sure that if we sent a man there, that they wouldn't sink into the morass.
3, 2, 1. Impact has occurred at 132550 Zulu. Impact has occurred.
Trail blazed, bridgehead achieved. Now NASA could send more instrumented probes out from Earth and down to the moon.
Probes showed that we could land on the moon, but no one knew exactly what the surface was made up of, if it was safe for humans, or how long people might be able to stay on it. Scientists tested their theories and debate continued, while NASA studied all the possibilities.
I think that over 95% of the major lunar surface features are volcanic in origin. I've come to this conclusion by the study of calderas and other volcanic features on the Earth.
Geologist Jack Green studied Crater Lake and other volcanic formations throughout the region. He was especially interested in Derrick Cave in rural Lake County. The 30-foot-high lava tube was once the site of a Cold War-era fallout shelter, stocked with provisions for 1,000 people. Green thought it might resemble caverns on the moon.
Why is that important? Part of the reason is because there were lava tubes on the moon. Well, maybe those lava tubes would be big enough to house the first lunar colonies.
By the early 1960s, the U.S. government had drawn up plans for colonies on the moon, but the plans required water. Green believed water could be extracted from volcanic rock. He worked with the Oregon State Department of Geology and Mineral Industries to test his ideas.
Jack Green had actually put together a project called Project Moonshine to determine whether water could be extracted from rocks in Central Oregon and then presumably would be able to be extracted from rocks on the moon.
And according to a department report, the The tests were promising.
1 hour after the dusty charge had been sealed into the furnace and the power turned on, the first drops of water emerged. Water continued to drip steadily for the next 6 hours.
But most scientists believe lunar volcanic activity was very different than the Earth's, and that the moon's craters had been formed by meteoric impact.
There's no doubt there's been volcanism on the moon, and in fact, most of the rocks on the moon are probably volcanic in origin. But we have to distinguish between the rocks and the craters that have been formed on them. Most of the craters have been formed after the rocks were already in place.
The idea of doing geology on the moon came from a scientist, Eugene Shoemaker.
Shoemaker spent part of his childhood living in Polk County, while his father earned a degree at the University of Oregon. He would be instrumental in the trainings that brought astronauts to the state.
As Shoemaker got his start as a graduate student working for the USGS, he started what he called it astrogeology. That term had not existed yet.
Shoemaker applied to be in the first group of astronauts. When he was rejected due to a medical condition, he pushed for the inclusion of astronaut geological training. He also felt strongly that some of the astronauts had to be scientists.
They got an education from studying the mineralogy and the petrology of geological samples to the point that they knew what they were looking at. It's estimated that the astronauts had the equivalent of a master's degree in geology.
With the training program that I put together, we ended up having about 4 or 5 days of field experience every month.
Of the 12 astronauts to walk on the moon, Harrison Jack Schmidt was the only professional scientist.
No, dead coming.
Jack Schmidt having a few problems.
With a doctorate in geology, he assisted in training other astronauts at sites all over the world.
The main thing was to expose them to as many different, say, geological experiences as we possibly could. Get them out in the field. Don't let them sit in the classroom. And to then put that into a context of an actual simulated mission where they had the equipment, they had the simulated backpacks, the cameras, just to get all those routine procedures to be routine. The hardest thing to teach pilot astronauts is that there are easy ways to sample with a hammer, and there are very hard ways to sample with a hammer. And for some reason, they kept taking the hard way.
Field training began in Oregon in 1964, when Apollo 7 astronaut Walter Cunningham flew himself in a T-33 jet trainer to Klamath Falls, Kingsley Field.
They were used to being photographed, they were used to being interviewed by journalists, and this was in some ways another public relations opportunity.
Governor Mark Hatfield and curious locals turned out to greet the NASA visitors.
Well, I remember that there was a lot of excitement in the community and people thought, hey, this is great.
Newspapers began calling the area Moon Country.
Scientists from the National Aeronautics and Space Administration consider Oregon Moon Country an ideal area for testing the astronauts' maneuverability on lava surfaces.
NASA's first tests were done in both fine pumice fields near Gilcrest and the rugged obsidian flows of McKenzie Pass.
It's in the middle of the summer, and the temperatures are, soaring over 100 degrees Fahrenheit.
The astronaut and NASA engineers struggled with a prototype spacesuit and its 50-pound oxygen pack. The faceplate steamed up, and Cunningham couldn't see.
Cunningham fell and tore his glove and felt that it was a little too easy to tear, and NASA people agreed, and they beefed up the spacesuit so that that wouldn't happen in space.
The tests were considered successful, and in the fall of 1964, 3 more groups were scheduled to arrive from NASA. In October, Eugene Cernan, Roger Chaffee, Michael Collins, and David Scott flew themselves to Klamath Falls. Another group arrived 2 weeks later.
I do remember that they were very excited about going out to Lava Butte, and man, this looks like really what it's going to look like up there on the moon.
A third trip was abruptly canceled when astronaut and test pilot Ted Freeman was killed in a plane crash. But over the next few years, more astronauts trained at sites throughout the region.
People in Oregon are excited about what this might mean for them as a local economy. And one person who was excited about this was Gene Roddenberry, with the idea that perhaps the Star Trek crew could start shooting in Central Oregon.
In the 1960s, Bend was a small town of about 12,000 people. The possibility of new space-related industry in the region provided an economic boost. Construction began on the Lava Lands Visitor Center. Local businesses formed a lunar base research group, and the University of Oregon established both the Pine Mountain Observatory and the Center for Volcanology.
The University of Oregon is one of the many places where geologists and scientists are studying types of volcanic lava that may exist on the moon or planets.
In 1965, the university helped host a lunar geological field conference in Bend, attracting scientists from all over the world.
The conference is basically an amazing international gathering of planetary geologists and volcanologists who come as far away as Japan and even the Soviet Union. And that was a pretty big thing.
In 1966, NASA returned to Central Oregon with its largest group, at least 22 astronauts.
Like everyone else, I was pretty excited at the thought that we'd send someone into space. I was pretty amazed that they'd come to Bend as part of their training. And of course the wondering, is it one of these guys that's going to go to the moon?
I mean, we took care of them. The NASA operation was a real big event in my time. There's no doubt about it.
Locals opened their homes and offered to be tour guides.
So when astronaut Jim Irwin was training in the moon country of Central Oregon, he was paired up with a local businessman named Floyd Watson.
The men stayed in touch. When Irwin was named to the Apollo 15 mission of 1971, Floyd Watson sent the astronaut a letter and a small rock, asking the astronaut if he would leave a piece of Oregon lava on the moon.
Then at some point, Watson got a letter in the mail with a picture of, an astronaut's boot track and a little tiny piece of Oregon lava sitting there right next to it. And Irwin had actually taken it up and set it on the moon and taken a photograph of it. And so there is a piece of Oregon on the moon.
Before the end of the 1960s, Kennedy's challenge was answered when Apollo 11 astronauts successfully walked on the moon.
We all sat glued to our TVs watching that thing thinking, my goodness, and the thought goes through your mind, oh, well, hey, these people trained here in our area. You can't help but feel a little bit of pride.
So Apollo was to put somebody on the moon and bring them back. After the first time, it then became more about the science and developing instruments that could measure and question, where did the moon come from?
The United States would put astronauts on the moon 6 times over a period of 3 years. Each landing pushed the science a little further. 1971's Apollo 14 resulted in so-called moon trees.
Stuart Rosa came to the Northwest and worked for the National Forest Service, then was deployed to Cave Junction, Oregon, and actually served as a smoke jumper in Oregon.
He returned to Oregon for field training. When he was chosen for a moon mission, the Forest Service asked him to take about 500 tree seeds into space to see how weightlessness would affect their growth on Earth.
And then once those seeds started growing, the seedlings were then distributed across the United States.
And all of a sudden, the whole country was gaga for moon trees. Everybody wanted one.
There were at least 6 moon trees planted in Oregon, including one at the state capitol, where it appears unaffected by its journey into space.
It was 15, 16, and 17 that really were the science missions.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample. This one right here? That's it.
The field training was critical because the science mission is a geologic mission.
Okay, we copy that.
When Apollo went to the moon, we had a understanding of maybe the relative history of the moon, but we didn't have absolute ages. The missions were designed to go and collect samples specifically from certain formations, and they came back with samples that allowed us to get ages and test various hypotheses of how we think the lunar surface had formed.
Apollo 17 had the biggest scientific payback of all the missions.
Geologist Harrison Jack Schmitt was on the final Apollo voyage to the moon. In 1972, he spent 3 days exploring the lunar surface.
Every rock that we examined had something new that I didn't expect.
Let's see if I can't crack the corner and get that contact.
Look at the boulders out there.
Every time we made a stop at a new station, there were some surprises. And surprises is what geologists like.
Him going to the moon in Apollo 17 resulted in a very accidental find. Probably had he not gone and he not been a geologist, he wouldn't have realized that this was something quite significant.
There is orange soil. Well, don't move it till I see it. It's all over. Orange.
That's it. That's the volcanic mix.
Somebody unplugged silver. Fantastic, sports fans.
We see those bright colors of alteration around volcanic vents. Well, in the final analysis, once we had the sample back, yes, it was volcanic, but it was volcanic ash.
From 1969 to 1972, astronauts returned to Earth with over 800 pounds of lunar samples.
This is rock 12,064, a volcanic rock picked up by the Apollo 12 astronauts in the Ocean of Storms.
In 1969, researchers at OSU and the University of Oregon were among a select group chosen to receive rocks gathered during the first moon landing.
The fact that the rocks, a sample from the moon, was going to be on campus, that's pretty exciting if you're a geologist.
There was a professor of nuclear chemistry named Dr. Roman Schmitt at Oregon State University who had developed a technique in the 1950s to actually take these samples and put them in a research reactor. And what he discovered and what he then reported out to the international community was that the moon was almost identical to the chemistry of the Earth. There was very little difference.
From a scientific perspective, it really changed our understanding of how the solar system and the universe, and even how the origin and evolution of life on Earth took place.
The main reason the moon is important in the general understanding of the solar system is that it has no atmosphere. It's never had any water erosion. It has no dynamic plates being formed and eaten up as the Earth does. And it tells us what the early solar system was like up to about 3.5 billion years ago.
The Apollo lunar samples seem to indicate that was a time of heavy asteroid bombardment of the inner solar system, including the Earth and Moon. It is also about the time when life is thought to have begun on Earth.
The samples themselves were sort of game changers.
In 2008, highly sensitive technology detected water in the same orange samples Schmidt found in 1972.
And it's a gift that keeps on giving. The researchers continue to go back to these samples. New analytical technology comes along where you can apply new techniques, get more higher resolution information, and that'll be going on indefinitely.
In recent years, researchers have found even more evidence of water on the moon.
If you look out to the future, the hope is that if we have a human presence on the moon, one of the things that we're going to need is water. And if there's a reservoir of ice there, that's an obvious place that we can base our activities from.
NASA encourages continued research and education through the National Space Grant Program, established in 1989 under former OSU professor Julius Dash.
What it's meant for Oregon is that I think students who have grown up in sort of the often ignored portion of the United States have had a chance to do great things in aerospace development.
A lot of my students here are very excited about the possibilities and the potential.
In Oregon, there's a variety of people doing planetary research, looking at the near space environment around planets. My own group looks at eruption processes on different moons.
For planetary geologists, unraveling the mysteries of the solar system begins by better understanding the world we live in.
So a lot of my research is primarily focused on laboratory experiments, so it's definitely always refreshing to actually get out in the field and see what these systems look like in real life.
Today, students and researchers continue to study in the same regions where Apollo astronauts trained more than 50 years ago.
I hope that I demonstrated the value of having experienced field geologists on the moon. I don't think the lunar sample collection from Apollo will ever be out of date. That's why you're exploring, is to see the things that nobody's ever seen before.
There's more about Oregon's moon country on Oregon Experience Online. To learn more, visit opb.org. Leading support for Oregon Experience is provided by the Harold and Arlene Schnitzer Care Foundation, Arlene Schnitzer and Jordan Schnitzer, and the Robert D. and Marcia H. Randall Charitable Trust Fund for Lifelong Learning. Major support provided by the Clark Foundation. Additional support provided by the contributing members of OPB and viewers like you. Thank you.